Alright, so this is 6.1, and it's solving one-step equations and inequalities. And today's the 14th, so make sure you guys have that down, put your name on it. The essential question is, how do we solve one-step equations and inequalities? And then there was something about graphing I wrote down. I think, and graph them. Let's just put that. And graph. So first we're going to solve, and then I'll show you how to graph it. And then we'll do a bunch of practice today. But we're starting off really easy. Notice it says one step. So there's only one step required to solve these. Later in the week, we'll do 2 steps to solve. Okay, but for now, just one step, and we're only going to look at adding and subtracting. Alright, so there was this thing in there, and it said equivalent equations. Equivalent equations are equations that have the same solution. Equations that have the same solution. You guys started playing around with these in elementary school a little bit, where your teacher would give you a math problem and they would look totally different. And then you'd have to figure out, are these equivalent? Would they actually have the same solution? And I saw them a lot on the SBAC test that we take, we'll take it in May. There was a lot of these where you had these algebraic equations and they looked really different, but they would still have the same solution. So it's a little bit confusing. So I'm going to give you guys an example of equivalent equations. So we're going to say right here, circle the equations that have x equals 3 as a solution. This is very similar to what you'll see on your test as well. Circle the equations that have x equals 3 as a solution. And then they'll give you maybe like 5 or 6 different choices on multiple choice. So maybe they'll have x plus 3 equals 6, and they'll do another one, x plus 1 equals 6. You might have x plus 3 equals 3, x plus 1 equals 4. I'll do 6 of them. X plus 6 equals 8, and x plus 2 equals 5. So we have 6 different choices, and we have to figure out which ones to circle. Which ones where x equals 3 will work. So let's start with the first one. If I put 3 in right here, does 3 plus 3 equal 6?
Yes.
So you can circle that one. Let's go down to the next one. 3 plus 3, does that equal 3? No. How about 3 plus 6, does that equal 8? No. Let's go over here. 3 plus 1, does that equal 6?
No.
How about 3 plus 1, does that equal 4?
Yes.
Circle that one. 3 plus 2, does that equal 5?
Yes.
Okay. Does that make sense to you guys?
Yes.
So you can have more than one equation be a solution where x equals 3. Or have a solution where x equals 3. Okay, so that's very similar to what you'll see, although these won't be as basic on a test. They'll be a lot bigger. Okay, let's solve some of these. We've had some practice, so I'm not going to do a ton. But let's go with example 1. Let's start off basic, like x plus 6 equals 4. And you guys could probably do these in your head when they're this simple, right?
Yes.
But we want to still follow the steps, because as problems grow bigger and bigger, you need to understand the steps. So what should I do with this plus 6? Anyone could say it.
Minus 6.
Subtract 6. And whatever we do to one side, we have to do to the other side. So normally I write them like this, and then I'll put a line under it. Some teachers actually have you put a line through the equal sign as well. Has anyone ever had a teacher do that? No? Okay. You can do that. It helps you separate it maybe. I don't feel like I have to put a line there, but I know that these 6's are now 0. So I just write x equals, and then what's 4 minus 6? Negative 2. And we can always check our solution, so we can plug it back in. So if I plug it right here, let's check over here. Negative 2 plus 6, does that equal 4?
Yes.
Yes, so that one is fine. We have our answer. Any questions on that one? It's a real basic one-step equation. Okay, let's do one where we have x on the other side of the equal sign. Sometimes it throws people off. So example 2, we'll have negative 5 equals x plus 8. So the reason it throws people off is because sometimes they try to move the negative 5 instead of the 8. Right? We're kind of used to going like left to right, but in this case we're going to go right to left. So we have to do what to the 8? Add or subtract it?
Subtract.
Good, because we do the opposite. Because what you're trying to do, remember in the videos they said you're trying to make the variable be all alone or isolate the variable. And this is minus 8. And this is x equals, well, what's negative 5 and a negative 8? Negative 13. And some people might get that wrong. They might put 3 or something different. But as soon as you plug it back in, you can see if you did it right or not. So let's plug it back in. So we have negative 5 equals, put negative 13 in for the x, and then plus 8. Does that work? Is negative 13 plus 8 negative 5? Yes. Okay? So I'll give you guys a U try. See if you can get this one. We'll do x plus 3 equals 1. Nothing tricky. Just raise your hand when you think you know. Okay, what's the answer?
Negative 2.
Good. So first you subtract 3 from each side. That gets x all by itself, or isolates the variable. And you get negative 2. Did anybody plug it back in to check?
Yes.
Okay, so we can rewrite it. Negative 2 plus 3, and that should equal 1. Raise your hand if you got that right. Any questions on that? No questions? Okay, so that's just adding, subtracting, basic one step. Now we're going to look at the inequalities. So that was the second lesson I had you guys preview. Okay, so I'm going to flip my page over here. Now we had a bunch of symbols. We had like a little chart in the book. You guys remember? Okay, so at the top of this one, write inequalities. Inequalities means it's not exactly equal, okay? It's greater than, less than, or greater than equal to, less than equal to, but not exactly equal, right? So if you have your arrow going this way, you'll see it as is less than. You might also see it in words, it'll say is fewer than, like in a word problem. Is less than or is fewer than. So if it's going the opposite direction, is greater than, is more than, and there's one more word I see a lot and it'll say exceeds. Exceeds. So something like that number exceeds the number of this. Now, this chart is going to be useful to keep around for when you take your test and there's word problems and you're trying to figure out what symbol to put in there. you'll look for these words and put the symbol in. Okay, so let's do the other two now. We have the arrow with the little line under it. This means is less than or equal to. It could also mean is no more than. Or sometimes it'll say at most. And that just means it could include that number. And then the opposite direction will mean all of these, but instead it'll be is greater than, right? Is greater than or equal to. It might also say is no less than. And instead of at most, what do you guys think that will be? At least. Good. Seems like when I see the word problems on tests, they're most often this one, the at least. So the solving is exactly the same. So let's do an example one with this. You have x plus 3 is greater than 10. So the only thing I've replaced now is the equal sign with an inequality, with an arrow. So how do we solve this? Pretend there's an equal sign, so what do you do with the 3? Subtract 3. That doesn't change, right? Same method. Subtract 3 from both sides. You have x is greater than 7. You can plug it back in. 7 plus 3. Okay? 7 plus 3 is not equal to 10, but remember anything x can be greater than anything other than 7. So a good way to check is to plug in a number that's bigger than 7. What's a number bigger than 7? 8. So is 8 plus 3 bigger than 10? Okay, what about 10? Is 10 plus 3 bigger than 10?
Yes.
So plug in any number greater than that, and if it works, you did it right.
So if you put
Okay.
5 million in work.
Yes. Any number bigger than 7 should work, right? And then to graph it, let's draw a little graph on the side. Now, when I'm graphing these, I don't put all the numbers on the number line because that would take days, right? So normally I'll just put a 0 because I have a 7 there, right? So I'll put a 0 over here and a 7 over here. And then in your book it talked about open and closed circle. Do you remember that?
Yes. Yeah.
Okay. So on the left side over here, let's do open circle. And it will either be this or this. So less than, greater than. And a closed circle means you just fill it in. And that one has the or equal to. So is our graph going to have the open circle or the closed circle? Open. So you put an open circle like this. And now you look at your arrow. X is greater than 7. So we said 8 would work, and 9 would work, and 10 would work, and 5 million would work, right? Where are all those numbers? Are they to the left of the 7 or to the right of the 7? So then we draw an arrow. I normally go from the top and I just draw going to the right. Any number bigger than 7 will work. Some people do this. They look at the direction of the arrow here and they try to copy it. But what happens if your variable is on the other side? Now you have to flip it. So I wouldn't rely on that 100% of the time. Just pick a number greater than, and if it falls to the right, then you know your arrow goes to the right. Okay? Okay, so let's do one more. Example 2. Let's do -6 is greater than or equal to n minus 5. So what do I do to solve this one?
you gotta subtract 5.
Or add 5, right?
5 from each side.
So add 5 to both sides. What is negative 6 plus 5?
1.
Negative 1, good. Keep the inequality sign there and put an n here. Now see, the first example my variable was on the left, now my variable is on the right. We can still graph it, so draw a little line to graph it. We have a 0 and a negative 1. And this literally means that any number less than negative 1 should work. What's a number less than negative 1?
Negative 2.
Negative 2, good. So is negative 2 minus 5 less than or equal to negative 6?
Yes.
Because that would be negative 7. That's less than, right? The negative numbers that are less than are getting bigger on the negative side. Would negative 1 work as well?
Yes.
Yes, because it's or equal to. So do I have a closed or open circle on this graph? Closed. Right here it says closed. Okay, and any number less than negative 1 or equal to that will work. So which way is less than negative 1? Left or right?
Left.
Left. Good. So you pick the numbers that'll work, and that's the direction your arrow goes. Any questions so far? Most people are good at solving these, but when it comes to graphing, they might mess up like their open and closed circle or their arrow left or right. So we do a lot of practice with graphing in here. Let's do a U-try, see if you guys can get it. So I'll do a really simple one for you, no fractions or decimals or anything. U-try number 1. So we'll do x minus 3 is less than 8. So solve it and then graph it. Raise your hand when you think you know. Anyone think they have a solution yet? A couple people. So x is less than what? What's the answer? X is less than 11. So we add 3. X is less than 11. And then we're going to graph it. I'm going to graph it right underneath here. Open or close circle.
Open.
Good. And now x is any number less than 11. So that means our arrow goes left or right.
It goes left.
Good. Any number less than 11 is going this way. Like 10. 10 minus 3 is 7. Is 7 less than 8? Yes. Raise your hand if you got that right and you were able to graph it. Okay, that's the trickiest part. So we're going to do some practice in the book and on a worksheet as well. So the page numbers are written up on the board, but I'll write them on here for you guys too. We're going to start with page 441, and it goes to 443.
I have a question.
Yes.
Why do we need a graph?
The graphing part of it, we only do with the inequalities. I think in elementary you guys graph the solution like x equals 3, x equals 2, and just put a dot on the number line.
Yeah.
But we're graphing the inequalities here because it actually where it's leading to is next year when you guys are graphing, you'll graph on a coordinate plane. And they're going to give you more than one variable. And you have to figure out the solution to 2 sets of equations. So it makes more sense to start graphing now just on a straight number line. And then next year you'll see it where the lines, like one line will go this way, one will go this way, and they intersect.
Oh, like that.
Yeah, and wherever they intersect might be their solution, or it could be like a shaded area. That's where it's going. It's not going to stay this easy like everything, right?
Yeah.
So what did I put, 1 through 6 for this one?
Yeah, you did.
And then 10, 15, 26, and 28. And then the next set of page numbers, it starts at like 501 and goes to what did I write? 503. 503, thanks. And that's number 1 through 8 and 21, 22. Okay, so since we're doing 2 lessons, that's why the page numbers are so far apart there.